Okay, so we're on polyatomic ions. Polyatomic ions are ions with multiple atoms. Now, the reason why these multiple atoms form structures that are ions comes from the fact that they're covalently bonded. Now, when you have a covalent bond, we'll talk about it later, we're going to be sharing electrons. So let's draw example carbonate, CO3. Now, CO3 is not happy like this, I promise. It's going to be very reactive. And the reason it is because carbon has 4 electrons and oxygen only has 6 each, okay? Whoops. Oxygen has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Now, carbon has 4, oxygen each has 6. So we're left with 20 atoms. So we need to find some way to bond them all together to be happy. So we're going to do, okay, if I let oxygen and carbon share this one, this will be happy. But carbon, Now, oxygen has 1, 2, 3, 4, 5, 6, 7. So let's say this one, carbon, shares its electron. But it needs to share 2 electrons with this guy. So they're happy. And if you have carbon sharing 2 electrons, and it only has 2 left, so it needs to share 1 with him and 1 with him. And they both have only 7 electrons, 7 each, 7 each. And this one has 8. Oh, uh-oh. And that's why it's going to go out and find more electrons. And be like, where are these? And it's going to stay in this structure. So it's this giant polyatomic ion walking around looking for electrons. And it's going to eventually find them. And so our carbonate is CO3 2 minus because it's looking for 2 electrons. And once it's 2 minus, it's found it assuredly. So that's a polyatomic ion. We'll talk about more covalent bonding in a minute. Now, to name polyatomic ions, we have a fun little list. You'll always be given a list. We have this list. All of them. These are all the polyatomic ions. We have this list. This is a much shorter list. Also, here are all your stock symbols. So here's our list of polyatomic ions. So let's practice naming them. And the rules are going to stay the same. Like ionic bonds, polyatomics, it's so easy. Okay, so easy. Once you figured out ionic bonds, oh my goodness, you'll get this so fast. So polyatomic ions. So let's say I give you NH4 with this nice little parentheses and a 2 and a little, let's do sulfate, SO4. Now, you say, Mr. Curlin, how the crap do I name that? And I'm like, I gave you the sheet. Look, look, look at the sheet. And you go, okay, so I have the sheet. So now I just got to find it. And you scroll down and you're like, Mr. Curlin, I can't find it anywhere. I'll be like, look again, because it's right. NH4 is right here. And once you find this, you know the name. Oh, so you go, oh, sorry, Mr. Curlin. Sorry for wasting your time. And I'll be like, you can't waste my time. I got no time to waste. Ammonium. Now we're finding SO4. I'm looking, scroll. Can't find it nowhere. Do scroll, and you're starting mumble. Mr. Curlin, I've given up. And I'm like, right there. And I see sulfate is SO4. And I'm like, oh, sick. And that's it. We're going from formulas to names. Super easy. Super duper easy. That's it. Nothing else. Ammonium sulfate. You can find it on the periodic table. You can find it in the polyatomic chart, or you can't. To go the opposite direction, not as easy, but pretty much the same thing. Let's say I'm given magnesium. Let's do, whoops, I'm going to say it, magnesium peroxide. Now, magnesium, I check my periodic table. 2 plus. Peroxide, fun little element. You might have heard of it from hydrogen peroxide. Is O2 minus 2. Crisscross rule. We're left with Mg2O2. And remember, simplify, divide by 2. We're left with MgO. Let's do one more example because that one is too easy. Say we're left with do copper, chromium 3. So I'll give you chromium. I don't know how to spell this stuff. 3. And I'm bonding it with dichromy. No, that's just a chromium. So I gotta go to chromium first. I see chromium. Chromium, 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 chromium. I can't find you nowhere. I can't find. Oh, there you are. Cr, either 2 plus or 3 plus. So I see it's 3. So I know. You gotta have 3. Cr, 3 plus. I go to my polyatomic ion chart. Chromate. CrO4. It's at 2 negative. You play the crisscross game. You're left with Cr2, CrO4, 3. Now, you say, Mr. Curlin, why do you have parentheses? I'm going to tell you why you don't have parentheses. And that's because this answer, Cr2, CrO12, is super wrong because chromate isn't bonding to 12 oxygens. Okay? And this chromate isn't bonding to a CrO12. Is also not Cr3O12. That's super wrong because chromate again isn't bonding to Cr2 isn't bonding to 3 other chromines and 12 oxygens. It's bonding to a complex that's chromium oxide 4, which is more like Cr, like an O, like an O. So it's bonding to this complex, which is all 2 negative. It's not bonding to 12 oxygens. It's not bonding to 3 chromiums. What else is a bad example of it not being? Oh yeah, my favorite. I've gotten this before. CR2, CrO43. No parentheses, no multiplication, no anything. That's wrong. You also definitely don't add it. CR2, CrO7. I've seen so many ways to get this wrong. It's not 4 plus 3. It's not 4 times 3. It's not. If I see this, you're wrong. Just do the parentheses. Save us all the headache. Parentheses. And that's how you do polyatomic ion.